Many people find maths dull, boring, uninspiring, abstract or even confusing, and it is regularly voted as one of, if not the, least liked subjects in school. This was also my personal experience. While I enjoyed the creativity of English and music, I disliked what I saw as the rigidity of maths. As I've grown older, I have developed an appreciation for maths. The old astronomer Galileo said maths is a language with which the universe is written. This is true in more than one way. For a start, mathematics does underpin our understanding of the universe and, unlike other sciences, if you prove something in maths it cannot be disproved. Also, maths is like a language, with numbers taking the place of words and symbols such as those for addition and subtraction taking the place of punctuation. From our earliest records of counting through to the infinity of numbers, with some fun task for you to pause and try, hopefully by the end of this video you too will have a new appreciation for maths. So with that in mind, here are 10 things you should know about numbers. 1. Our daily number systems are a bit of a mess. Although the earliest evidence of numerical symbols dates back to around 5,000 to 6,000 years ago, there is archaeological evidence to suggest that humans have been counting for close to 50,000 years. A leg bone of a baboon found in the 1970s in the Lobombo Mountains of South Africa was discovered to have 29 notches carved into it. The bone was dated to around 43,000 years ago. Our systems of counting have come a long way from carving lines into animal bones, and today we use the decimal number system, our numbers 0 to 9, and what is called a base 10 system. Counting in tens works well since we have 10 fingers and first learned to count by counting our fingers. However, not everything in our daily lives uses a system based on groups of 10. Originally there were 10 months, however there are 12 new moons in a calendar year, so January and February were added to the start of the calendar. The names of what had been the 5th and 6th months, Quintilis and Sextilis, were changed to July after the Roman Emperor Julius Caesar and Augustus after his successor Augustus. This messes up the names of the final 4 months, September, October, November and December, which were so named since they were the 7th, 8th, 9th and 10th months. Groups of 12 are also used in measurement since there are 12 inches in a foot. We also regularly use a base 60 number system without thinking about it. An hour is broken down into 60 minutes and each minute is broken down into 60 seconds, owing to a number system developed by the ancient Sumerians who lived around 6,000 years ago. We see the sunrise 365 times in a year, which the ancient Egyptians approximated to 360 or 6 lots of 60. This is why we have 360 degrees in a circle. Throughout the years there have been many number systems which have appeared and disappeared, and this mishmash of our daily number systems owes itself to the melting pot of cultures, languages and ideas throughout history. 2. 0 is an even number. Despite evidence that humans have been counting for almost 50,000 years, 0 is a number that was largely ignored for a lot of this time. Part of this is because in the early days of counting there would be no need to mark a bone to show 0. As our skills developed, numbers were used for trading goods, and you're not going to trade 0 of anything to receive 0 of anything. Approximately 1,800 years ago, the first use of 0 emerged, first as a dot and then becoming the circle we know today. We use 0 as a placeholder, like in the number 101, which means when we break it down that we have one set of 100, 0 sets of 10 and one set of ones. 0 is also essential to our digital age, with computers operating using a binary system where sentences are constructed of ones or zeros. For example, a switch in a computer can either be on, 1 or off, 0. If you've heard of computer bits, this is a shortened version of binary units. Now we've had a brief look at the rise of 0, let's find out why 0 and consequently any number ending in 0 is an even number. An even number is defined as any number which, when divided by 2, produces a whole number as the answer. For example, 4 divided by 2 gives the answer of 2, a whole number, whereas 3 divided by 2 gives 1.5, not a whole number. Therefore 4 is an even number and 3 is an odd number. When you divide 0 by 2, you get 0, a whole number, so 0 is an even number. 3. Prime numbers keep us safe online. A prime number is any number that can be evenly divided by itself and 1. For example, let's look at the number 5. If you divide it by 5, you get 1. If you divide it by 1, you get 5. If you try to divide it by any other number, you will not get a whole number as an answer. Therefore, 5 is a prime number. Eratosthenes of Cyrene was the first person to calculate the circumference of the Earth, and he also devised the sieve of Eratosthenes, which is a way to sieve out prime numbers. If you had a grid of the numbers 1 to 1000, you would start by crossing out 1, which is not a prime number. 2 is the first and only even prime number, so it stays. However, you need to cross off every even number because they can all be divided by 2. You then do the same to multiples of 3, 5, 7, 11 and so on. Any numbers not crossed out are prime numbers. Larger prime numbers are calculated using the formula 2 to the power of p minus 1. When you start getting into higher prime numbers, it takes a long time to calculate these. For example, it took someone 3 years of Sundays to prove that a number previously thought to be a prime number actually wasn't. The currently largest known prime number has almost 25 million digits in it. The fact it takes a long time to figure out prime numbers is a key part of internet security for online shopping. When you submit your bank details to a website such as Amazon, this information is stored away in a virtual lockbox, the key to which is 2 prime numbers, each at least 617 digits long, that are multiplied together to create the passkey. Since it takes an incredibly long time to work out which 2 prime numbers may have been used, the passkey is safe and your bank details are secure. However, nothing is infallible, and passkeys have already had to be improved to protect against hackers. 4. Pi is known to 62.8 trillion digits. Pi is one of the most famous numbers in all of mathematics, to the extent that it even has a day named after it. Pi starts 3.1415926 and is what's known as an irrational number, a number that cannot be written as a simple fraction, but a fraction can provide an approximate number. The Babylonians used 25/8, which is 3.125, and a mathematical papyrus from Egypt used 256/81s, which is 3.16. However, even better is 22/7, which is 3.143, and this is why 22nd July is known as Pi Approximation Day. So how do we know pi to a staggering 62.8 trillion digits? This is a work of Swiss researchers who in 2021 had a supercomputer crunch the numbers for 108 straight days. To put this into perspective, if you were to try and say all of the 62.8 trillion digits at a speed of 1 digit per second, it would take you almost 2 million years to get to the end. The furthest anyone has managed to recite the sequence by memory is to the 70,000th digit, which took them 10 hours. There are some interesting patterns that pop up in the digits of pi. For example, in the first 1 trillion digits, 8 is the most common number. From position 768 in the sequence, there are 6 9s in a row. It takes until the 17,387,594,880th digit before the sequence 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 appears. You can even use an online tool to search for important dates in your life to see where they appear. I'll put a link in the description to that website. 5. The angles of a triangle don't always add up to 180 degrees. It's one of the rules taught in school while doing shape that the 3 angles within a triangle will add up to 180 degrees, and this rule is followed for pupils to be able to calculate the size of a missing angle. This rule, however, only works on flat surfaces. If you were to travel from the North Pole down to the equator, travel along the equator, and then travel back up to the point in the North Pole where you started, you'll have travelled in a triangle on the Earth. However, where you turn to travel along the equator and then where you turn to travel back to the North Pole are both 90-degree angles. That gives us a total of 180 degrees, but there is still the angle at the North Pole to be added on, so the triangle must add up to more than 180 degrees. In fact, a triangle drawn onto a sphere can have angles that total up to 540 degrees if the triangle covers half the surface area of the sphere. In the opposite direction, triangles can also have angles that add up to less than 180 degrees if they are drawn on a shape that looks like a horse's saddle or a Pringle. On this shape, the corners of the triangle are pinched, reducing the size of the angles. Astronomers can use this knowledge to learn about the curvature of the universe by drawing a triangle between Earth and 2 distant points in the universe. If the angles add up to 180 degrees, the universe is flat. If it is more than 180 degrees, the universe is curved like a sphere. And if it's less than 180 degrees, then it is curved like a saddle. It turns out that based on these calculations, the universe is flat, leading to a further development of the Big Bang Theory to include the rapid expansion of the universe. All that from a simple triangle. 6. Google works based on an old bridge problem. The city of Königsberg, which was renamed to Kaliningrad in 1946, was historically famous for its bridge problem. The city has the Pregel River carving a path through it, creating two islands in the middle of the city. Back in the 18th century, the different parts of the city were connected by 7 bridges, which had people wondering if you could travel round the city, crossing every bridge once without retracing your steps. The Swiss mathematician Leonhard Euler worked out that it was impossible. Not only that, but Euler worked out that some shapes would be impossible to draw, and this is what's called graph theory. His calculations were based on nodes, points of a shape, and the edges of the shape. If all of the nodes of a shape have an odd number of edges joining it, the shape is impossible to draw without retracing your steps. However, if only 2 nodes in the shape have an odd number of edges joining them, you can draw the shape without retracing your steps, but you must start at one of these nodes and finish at the other. Look at these 2 shapes and work out which one can be drawn without lifting your pencil and going back over a line, and which one is impossible. Pause the video to see if you can work it out. You may have noticed that the shape on the left is impossible to draw without having to go back over one of your lines. Another way to refer to these edges is networks, and this is where Google comes in. Google uses mathematics in its algorithm, where websites are nodes and hyperlinks between websites are edges or networks. A link from an authoritative website counts for more than a random person's web page, and these websites then appear closer to the top of the search page. Facebook does the same, with individuals as nodes and networks being the connections between these people, such as family and friends. Graph theory also works for apps that recommend music or films that you might like, weighting networks based on user recommendations. So from a seemingly innocent bridge problem, billion and trillion dollar companies have arisen. 7. Mathematicians are obsessed with cake. When faced with a round cake, I'm sure most of us would cut out a slice as a triangular wedge. The only issue with this is that it leaves some of the inside of the cake exposed and therefore likely to dry out. In 1906, Francis Galton wrote an article published in Nature magazine entitled "Cutting a Round Cake on Scientific Principles," in which he stated that first you have to make 2 cuts with parallel lines down the middle of the cake. You can then remove this section and push the 2 sides together. The next time you cut the cake, you should use 2 parallel lines across the cake and again push the remaining pieces together. This means that by day 3 the cake should still be suitably moist for you to enjoy. Mathematicians have since taken cake problems to whole other levels with the fair cake cutting problem. To fairly split a cake between 2 people, person 1 moves a knife over the top of the cake from left to right. One of the 2 people must say stop when they believe the knife to be in the middle. The person who calls stop gets the left-hand piece, thinking it is half the cake, and the non-caller is happy, thinking they have more than half the cake. Otherwise, they'd have said stop already. It's a win-win situation. It gets more complicated when 3 people are trying to evenly share a cake. However, a solution was established, though a bit complex, using 5 cuts at most. At this point, it was thought solutions for more than 3 people would not be possible, but mathematicians are tenacious, especially when it comes to cake. In 2016, a solution was developed to have 4 people equally share a cake, and it would only take a maximum of 203 cuts. The upper limit of cuts to evenly share a cake between 5 people is a 2 followed by 2,184 zeros, so it's probably better if everyone just has their own cake. 8. The Monty Hall Problem. Named after an American game show host, the Monty Hall Problem is a mathematical problem involving probability that really confuses people. So for this part of the video, we're going to play a little game. Here are 3 doors, A, B and C. Behind one of these doors is £10,000 and behind each of the other 2 is a rock. You have a 1/3 chance of selecting the right door. So imagine you're on this game show and you chose door A. At this point, the host opens up door C to reveal a rock and then comes back to you with an option. Are you going to stick with door A or switch to door B? Pause the video and make your choice. Did you stick with door A? A lot of people do. Thinking with only doors A and B, then there must be a 50-50 chance that it is behind door A. That's not the case though. When door A was chosen, there was only a 1/3 chance of you picking the right door. By sticking with door A, you are sticking with a 1/3 chance, but by switching to door B, you have a 2/3 chance of winning the money. In a situation like this, you should always switch because that gives you the greater chance of winning the money. But don't just take my word for it, let's look at the possible ways the money can be arranged in the following chart. Let's still imagine you pick door A to start with. In the first scenario in the chart, the host opens door C to reveal a rock. Between A and B, you stick with A and win the money. However, in the second scenario, the host opens door C, you stick with door A, but the money is behind door B. And in the third scenario, the host opens door B, you stick with door A, but the money is behind door C. From that chart, you'll see that switching doors will win you the money 2 out of 3 times, and sticking with your original door will only win you the money 1 out of 3 times. Hopefully this helps you understand this tricky problem, which has been the root of many internet debates. 9. COVID-19 was an example of exponential growth. Exponential growth is a process that increases quantity over time, and the amount that the quantity increases by is relevant to the size of what is increasing. The larger something is, the bigger its increase. For example, imagine you have a magic bank account. You start with £1, but your money doubles every day. How many days would it take for you to reach or go over £100? Pause the video and try to work it out. By day 8, your money will go over the £100 mark. Let's break it down. Day 1, £1. Day 2 doubles to £2. Day 3 doubles to £4. Day 4 doubles to £8. Day 5 doubles to £16. Day 6 doubles to £32. Day 7 doubles to £64. Day 8 doubles to £128. Although it started off with just small jumps at the start, you'll notice that as the amount of money got bigger, so did the jumps in the amount you have. This is exponential growth, and unfortunately, we get a good taste of this during the COVID-19 pandemic. You may remember hearing about the R number. That's how many people you are likely to infect with the virus if you are out coming into contact with people. Near the start of the pandemic, the R number was thought to be around 3. So if you were not isolating and following precautions, you could infect 3 people. However, they would go on to infect 9 people, who would go on to infect 27 people, who would go on to infect 81 people. By this point, you have now been responsible for the infection of 120 people due to exponential growth. Technology is also going through an exponential growth and has been for some time. Moore's law states that the number of transistors in a computer chip will double every 2 years. For example, transistor radios used to have between 4 and 8 transistors in them around 70 years ago. Today, the iPhone 13 has around 15 billion transistors. That's the power of exponential growth. 10. The infinity hotel is never full. This is a bit of a cheat in a video about numbers, because infinity is not really a number. If something is finite, it has an end. Infinity is a concept of endlessness. This is something which for the human brain can be a bit counterintuitive and confusing. What's even more baffling is that there are different sizes of infinity. That gets really complex and is not something I'm going to explore in this video. Instead, we're going to look at the concept of the infinity hotel, first discussed in the 1920s by David Hilbert. Imagine a hotel that is fully booked when another traveller comes in and asks for a room. No problem, says the receptionist, who goes on to move every guest up a room number. So room 1 goes to 2, room 2 to 3 and so on. This rule for the move is room n plus 1, where n stands for number. This new guest now takes up room 1. The next night, a group of 15 business owners turn up for a conference. This is not a problem for the receptionist at the Infinity Hotel. This time she moves every guest up by 15 rooms, so room 1 goes to room 16 and so on, following the rule of room n plus 15. If an infinite number of people and an infinite number of coaches turned up, this still wouldn't pose a problem. Everyone in the hotel and all those checking in could all occupy rooms that are prime numbers, since there's an infinity of prime numbers. However, there's also an infinity of non-prime numbers, so the hotel still has an infinite number of empty rooms. Like I said at the start of this section, infinity is counterintuitive, and the Infinity Hotel, also called the Hilbert Hotel, was devised to show how counterintuitive infinity is. There are 2 final thoughts I want to leave you with. 1. We have come a long way as a species since those early days of scratching lines into monkey bones with huge technical advances. Underpinning a lot of the developments of our civilization has been mathematics. It is a part of our daily lives, whether you are thinking about the calculations and numbers you're using as mathematics or not. 2. Mathematics tells stories just as well as any book, if you understand what you're looking for and how to read its language. From ecologists finding stories in statistics to astrophysicists discovering the laws of the universe. Hopefully this video has helped bring some more insight into the wonders of numbers and perhaps sparked more of an interest in some element of mathematics to make you more curious. Thank you for watching this Things You Should Know video. The majority of the information for this video came from 10 Things You Should Know About Numbers by Colin Stewart. I was only able to touch on a tiny fraction of the huge amount of information in this book. You can subscribe to the channel by pushing the button here, and I've added links here to my other things you should know videos and underneath to my STEM activity videos and my STEM career interviews. This has been STEM with Mr. N, exploring 10 things you should know about numbers.